Once upon a time, in 1300 BC, there lived a man and a woman who wanted a better house, a more substantial house. They decided to see what would happen if they added burnt limestone to their house. Splat, splat, splat.
Reinforced. Protected from weather. Innovative.
I love my house.
Poof. Poof.
And this was the beginning of the development of cement. And from here, society could only learn exponentially. And they lived happily ever after. Early cementitious mixtures were created with crushed ingredients in a mortar, starting with dirt, then sand, then water. Sploosh, 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 sploosh. And now we have concrete paste. Let's get that bad boy out. Splat, splat. And now we have basic bricks. And we can make more bricks, and then even more bricks. And then we can combine those bricks
Boom.
together.
Bang. Boing.
A brick wall made entirely of concrete blocks. For this example of concrete principles, I have used Portland cement. The raw materials to start with are limestone and clay or shale. These are obtained through quarrying and crushing. Then we have to mix these components up.
Bang. 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 Bang.
To make crushed limestone, clay, and shale into one mixture, and then into the kiln. And as a byproduct, you get clinker, which is then mixed with gypsum. And now you have Portland cement. That, once mixed with water, can be poured to form hard concrete. Sploosh, sploosh. Like pathways, architectural structures, foundations, highways, bridges and overpasses, car parks, supporting structures, and structural fences. Let's talk about innovative concretes. This is a self-healing concrete, which uses healing capsules, also known as microcapsules, to seal and repair cracks in the concrete. Watch what happens when the concrete breaks. The capsules release a healing agent when the shells are broken. And in under an hour, the agent seals the cracks and the concrete was repaired. For the next innovation, 3D structures are created using a 3D printer. The machinery prints the concrete onto site with minimum labour to ensure the job is completed efficiently. This design is likely to be the future of creating cheap and affordable houses, as it is fast and the machinery is easily transportable. Here you can see two different concrete textures, one with a more refined solution and one with larger rocks and clinker inside. The difference between the two relates to how they react towards the water. Now let us see what happens when rainfall interacts with the concrete. As you can see, the water goes through the pervious cement but drips off the Portland cement side. This is due to the larger clinker in the pervious mixture. The last innovation is Martian concrete, a futuristic concrete designed to be used on Mars. This concrete form is designed to be utterly self-sustainable on Mars and can be easily transported on a spaceship. All the astronauts will need is a 3D printer. Once landed, they will simply have to set up the machine. They will need to collect Martian soil and mix it with molten sulfur, which very similarly reflects Portland concrete. And from there, the 3D printer can construct any building they would need on Mars, whether a house, a laboratory, or just practice buildings. This method is easy to power, sustainable, and environmentally friendly. And this technology is the future of concrete and shows how easy it is for a machine to form a building made entirely of concrete. The future of concrete structures also leads to the moon, where once again 3D printers are used to construct a building with a concrete paste that can be molded and formed more exact than the mixture used on Mars. This structure is a lot more advanced and uses multiple materials, not just concrete, and therefore can create buildings of a very complex stature within record timing. The future of concrete is here, and its possibilities are endless.